Hey guys, let's take a look at applications of exponentials. So it's your favorite word problems. I know, you are so excited. So here's the first one. Erica invested $2,000 in a bond that pays 1.8% interest, compounded monthly. How long will it take for her investment to double? So the first thing we need to realize or figure out is what formula we're supposed to use. So since they're talking about something compounding monthly, that means that we're going to have to use that equation that we learned on our first day. A equals P times 1 plus R as a decimal over N T power. Okay, so we can go through and plug in what we know from the problem into this equation, and then we're trying to figure out how long it will take, so that means we're going to solve for t right here. So she invested $2,000, so that means that $2,000 is your principal. So that means that $2,000 is going to go in there, or 2,000 is going to go in for principal. Now, they want to know how long it's going to take for her investment to double. So, double $2,000 is $4,000, and that's A. A is the amount afterwards. So, double 2,000 is 4,000. Good deal. By the way, here in a second, when we start solving, we're going to divide by 2,000 on both sides. So, you're just going to end up with 2 over here. One thing that's going to happen pretty often is they're going to talk about things doubling or halving or something like that. You can literally double it like we did right here, or if you know afterwards you're going to divide by that number and end up with a 2 over there, you can go ahead and skip that step. But if that doesn't make sense to you, go ahead and plug it all on in and solve. Okay, so double our investment of $2,000 is $4,000. And then we'll have 1 plus. My rate is 1.8%. If I put that into a decimal, that's 0.018 over. N is the number of times per year that it's compounded. So since it's compounded monthly, that happens 12 times a year. We decided N was 12. And we don't know what T is, so we're just going to go ahead and leave it as T. So here's a couple of things that I would do first to solve. Like I said, I'm going to divide by 2,000 on both sides. So since I doubled it, I know this will just have to be 2 equals. Another thing that I think is helpful, right here, if you pop 1 plus 0.18 divided by 12 into your calculator, you get a decimal that is not terrible. So I'm going to go ahead and do that. When I pop that in, I end up with 1.0015. And that is to the 12t power. So if you remember from our last video, what I like to do to go through to solve this guy is I take the log or the natural log of both sides. It doesn't matter which one. We'll go ahead and take the natural log because we're going to be taking the natural log a lot this lesson. So we'll take the natural log of both sides. So now I have the natural log of 2 equals the natural log of 1.0015 to the 12t power. All right. So remember, the reason we want to take the log of both sides is because we have that property that says my exponent is allowed to come out front and no longer become an exponent. It just gets multiplied out front. So that's what I'm going to do. I'm going to bring this out front. So now we have the natural log of 2 equals 12t because my exponent gets to come out front. And then natural log of 1.0015. All right. Now, t is being multiplied by 12 and the natural log of 1.0015, right? So since they're being multiplied, to undo that, we have to divide. So to get t by itself, I have to divide by 12, and I have to divide by the natural log of 1.0015. All right. So if somebody is asking you for an exact value, a lot of times in problems they're going to ask you for an exact value. The exact value is going to be right here, the natural log of 2 over 12 natural log of 1.0015. Remember that natural logs are not, those are not something that can cancel out right there. They're not going to divide away. The thing that undoes a natural log is an e. So natural log of 2 and natural log of this stuff, it's an operator. You can't cancel those out. So that would be my exact value. So otherwise, what you're going to do is you're going to take natural log of 2 divided by 12, natural log of 1.0015 to get an actual value. And when you put that into your calculator, you should get 38.5. And that is in years. All right, let's take a look at a couple more problems. Okay, so a bacteria population doubles every 8 minutes. If the population begins with 1 cell, how long will it take to grow to 100 grams? I think I meant to put 100 cells. Not I think I know. The next problem has to do with grams. That's supposed to be cells. Okay, but the spirit of the problem is the same. So when we talk about bacteria, it's not like the bacteria get together and every 8 minutes they all, plan and they're like, all right, okay, get ready, we're going to double, and go. And all of a sudden there's another cell. And 8 minutes later, go. And all of a sudden there's, double the cells. So it's not quite how it works, right? They double kind of how they please. So this growth is natural growth. It's natural how bacteria grows, right? It's not something man-made. It's not a bank account or something like that. So this means that it is growing continuously. So that means we're going to use the natural base. So I really hope that right now you might want to go back and watch the number file video for E. It's awesome. It's really interesting how that approximation of E goes through and, all those different ways to find E, and that describes something so natural. It's cool. Watch it. Sorry. I'll leave you alone. Anyways, E. Be like it. It describes natural things. It describes our world. So, that means that when we're using this, we're going to have to use A equals PE to the RT power. So whenever we're dealing with something natural, like bacteria or population or substances that, like here in a minute, we're going to have plutonium, things like that, you're going to use this guy. The only time you are going to use this equation is in this sort of situation where something is compounded on a very arbitrated basis. So monthly, yearly, quarterly, things like that. Otherwise, we're going to rock this guy. Okay, so first of all, a lot of people get into this thing of thinking that my rate is 2 because it doubles every 8 minutes. That's not true. The fact that it doubles every 8 minutes is going to help us find our rate. So the first thing we need to do is we need to find R. So, from the fact that it doubles every 8 minutes, that's going to help me find r. So if I started out, remember I'm going to plug things into a equals p e to the r t. So if I begin with one cell, e rate, after 8 minutes for my time, I'm going to double, so then I'd have 2 cells, right? So now I have to go through and solve for my rate. So I can either multiply this by 1 or divide by 1 on both sides. So I have 2 equals e to the, and then r times 8 feels weird. I'm just going to put it as 8r. Then we have to get rid of our e. The way we undo e is natural log. So we'll take the natural log of both sides. The natural log of 2 is just the natural log of 2. And then over here, natural log and e cancel each other out. So we're just left with 8r. Then to get r by itself, we have to divide by 8. So r equals the natural log of 2 over 8. So leave it just like that, or you can put it into your calculator. Now, here in a minute, we're trying to figure out how long will it take for a cell to grow to, or for the bacteria population to grow to 100 cells, right? So we're going to want to put this number into there. Now, if you put the natural log of 2 over 8 into your calculator, it is disgusting. But what we can do is we can go ahead and store it into our calculator, and we can use that value a little bit later. So here's how we're going to do that. So we're going to go ahead and type that in, natural log of 2 divided by 8, and then we'll press enter. So we'll get this number that's about 0. There we go, 0.0866, blah, 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 blah. So it goes on and on and on forever, right? So it's pretty gross. So what we're going to do is we're going to store this. So we're going to press the STO right here, press store, and then he's going to be like ants. And that little arrow, that means the answer, we're going to save it somewhere. So what you're going to do is you're going to press alpha, and then you're going to pick a letter like A. And then press enter. And then it will just say that one more time. So now when you go through and plug something in and you want to use that value that you found for R right here, you just have to go to alpha A, and then it'll use that number for you. So that way you don't have to figure out like, oh, did I round too soon? Did I not round enough? That's the way you can do it. So anyways, that is about 0.087. Okay, so now we want to go through and solve for t now that we have these pieces of information. So we know that the population begins with one cell, so that's how much we started with, so that's kind of the principle. We want to know how long it takes to get to 100 cells, so that means that A is 100. That rate is my 0.087, there we go, T. When I do put this into my calculator, though, I'm going to use that number that's stored. I'm just going to put that rounded value there for me right now just as a placeholder. If it makes more sense to you to put the R there and then just know, hey, I'm supposed to go back to store, or maybe you keep it as, you stored it as A, so you put that as the letter A so you know what to go back into your calculator and put, cool. Okay, so let's start solving for t. So at this first point, we can either divide by 1 on both sides or multiply e by 1 on that side. Either way, when we simplify this, we have 100 equals e to the 0.087t power. So the way that we undo an e is a natural log. So we're going to have to take the natural log of both sides. So over on this side, natural log and e cancel each other out. On this side, I'm just left with the natural log of 100 equals. And so on this side, since natural log and e canceled out, I have 0.087 t. So now to get t by itself, we'll just have to divide by that rate that we found earlier. So in my calculator, it's going to look something like this. The natural log of 100 over a. Because remember, what's saved in there is that 0.0866 blah, blah, blah from my calculator, right? So all you have to do that is just put in natural log of 100 divided, natural log of 100 divided by, and then you will just click alpha and then A, because that's where we stored him, and press enter. Okay, so sorry about that. So that means that we end up with 53.2. And if we go back and look at our units, that means that we are in minutes. So we will have 100 bacteria in 53.2 minutes. All right, one more. Here we go. So plutonium has a half-life of 5 hours. How long will it take a sample of 500 grams of plutonium to decay to 5 grams? So first of all, what's a half-life? So what happens with a lot of radioactive material is it decays so that half of a sample is left after an amount of time. So let's say that there are 10 grams of plutonium. After 5 hours, only 5 grams are left. Or, okay, let's think about this a little bit bigger. If there's 100 grams of plutonium, after 5 hours, there's 50. After 10 hours, there's 25. Do you see what I'm saying? So every 5 hours, there's half of that amount. So, just like on this last one where we had to figure out what the rate was because it doubled every so many minutes, this is going to cut in half so many hours. So that means I have to go and actually solve for the rate before I go and solve for time, because that's what I'm actually trying to solve for my problem. So first, let's go ahead and solve for the rate. So it says that the half-life is 5 hours. So we're trying to find R right now. And we're doing that with the fact that the half-life is 5 hours. So, whoopsies. Remember, since plutonium decaying is a natural thing, it's not a man-made process, we have to use A equals PE to the RT. So to find R, let's say we started off with 1 gram of plutonium. We know we are going to have half of that sample, so A will be 1/2. E, we don't know what the rate is, times, and then we have half of this after 5 hours, so I'm going to put 5 in for T. So now we'll go through and start solving. So we can either multiply by 1 over here, divide by 1 on each side, whatever you want to do to simplify. We end up with 1/2 equals E to the 5R when I multiply R times 5. Now I need to get rid of E. To undo an E, I need to take the natural log. So I'll take the natural log of both sides. I'm left with the natural log of 1/2. on the left side. Over here on the right, my natural log and e cancel each other out, so I'm just left with 5r. So then what I'll do is I'll divide by 5 on both sides to get r by itself. So r equals the natural log of 1/2 over 5. The next step that I'm going to do is go ahead and put that into my calculator. So I'll put natural log of 1/2 divided by 5. So I got negative 0.138 blah blah blah. It makes sense that my rate is negative since it's decaying. My rate should be negative. So remember, I'm going to click right here to store. And then since I'm done with that last problem, I go ahead and I save everything in A. I'm not sure why, it just feels good. And I'm going to press enter to save it for a little bit later. So now we want to know how long it's going to take a sample of 500 grams of plutonium to decay to 5 grams. So we're going to keep on using this equation. We're going to start off with 500 grams, so that will be P. We want to end up with 5 grams, so that will be A. That rate was negative 0.01, but we're just going to use that value from the calculator, so I'm just going to leave it right there. And then pop a T on there. Okay, so the next thing we're going to do is start solving for T. So we have to divide by 500. So 5 divided by 500 is 1 over 100. You could absolutely leave it as 5 over 500, but for some reason that makes me sad, so I'm just going to keep it like this. Equals e to the negative 0.1 t. So now I need to undo that e, so that means I need to take the natural log of both sides. So now I have the natural log of 1/100th. Actually, let's write this differently. 1/100th. That's a little bit nicer, right? Equals, and then over here, natural log and e cancel each other out. So I'm left with negative 0.1 t. Now I need to get t by itself, so I will divide by that rate that I had earlier. But remember, this is the value that I stored in A, so I'm going to go ahead and use that guy. So I'm going to type in natural log of 1/100th divided by my new rate. So I'm going to have to press alpha and then A. Sorry about my nails. I'll get, fix them up a little bit. We end up with 33.2. So T equals 33.2, and then we'll look and see what units we're in for time, and that's hours. Good deal. All right, so after this, technically we're done with exponentials. I think what I'll do is I'll try to throw together some sort of kind of review in Schoology for you guys to try it out and see if it works out for you. If you're looking for any other kind of assessments, I can put some, or not assessments, but like practice. I will put some links on IXL, on Schoology to IXL for you. If you're having trouble because it's saying you can only do 10 problems, right-click the link into one that you want to go into, and just go into an incognito tab, and it should let you keep on doing more problems from there. But I'll give you text instructions on all of that for a little bit later. So let me know what's working for you, what's making sense, what's not making sense, and we'll get back together a little bit later. Okay, I miss you guys so much.